pick up where we left off in the last video. We're going to look at some more examples of actual partial fraction decomposition. Some of these denominators should look familiar. And what I'm going to do here is go through the steps. Now, we have already talked about how to set up the form, and that is to make sure that you have the denominator factored. And if we factor this, all you'd have to do is kind of look back in the videos from the last one. You'll notice that this, if you factor out at x, leaves x squared plus 4x plus 2, or x plus 2 quantity squared. And we said that this fit the form a over x plus b over x plus 2 plus c all over the quantity x plus 2 quantity squared. So I'm going to get this equal to this. If I combine these, I have to get a common denominator, which is this guy. So I'm going to have to multiply here, top and bottom, by x plus 2 quantity squared. I'm going to have to multiply top and bottom here by a factor of x and a factor of x plus 2. So that's going to be b times x times a factor of x plus 2 all over my common denominator. And then I'm going to have to multiply here top and bottom by x. Now, I'm going to put it all over my common denominator. And I'm going to combine here. Now remember, x plus 2 times x plus 2 is x squared plus 4x plus 4. So if I multiply through by a, I have ax squared plus 4ax plus 4a. That's this numerator. Plus, here I distribute, I have plus bx squared plus 2bx. And then here I just have plus cx. Now, like I did in the previous example, I'm going to try to combine my like terms here. So I look for my x squareds. I have two of those. So this becomes a plus b x squared. And then my x's, I have three of those. So that would be plus 4a plus 2b plus c x. If I factor out the x out of this guy here, and this guy here. That leaves the plus 4a as my constant, and that's all over my common denominator. Well, remember, this has to equal the original. So this coefficient has to equal -1, this coefficient has to equal 3, and this constant term has to equal 8. So I have a plus b is equal to -1. I have 4a plus 2b plus c is equal to 3, positive 3. That's right here. These two are equal. These two are equal. And I'm equating them. And then the constant terms. These two are equal. So that's going to give me 4a equals 8, which is really a nice equation because it only has the one variable. I divide by 4, I get a is 2. Once I know that a is 2, 2 plus b, plugging it into this first equation gives me b is -3. Once I have a and b, I can plug into here and find c. So this is 4 times 2 plus 2 times -3 plus c is equal to 3. That's 8, and -6 is 2 plus c is equal to 3, so c is equal to 1, unless I made a silly mistake, because I'm getting into a little bit of a rush. So now I have a, b, and c, and I can put them right back into, right here, this form. So the original problem, the opposite of x squared plus 3x plus 8, kind of recapping here, all over x to the third plus 4x squared plus 4x is equal to a over x, so that would be 2 over x, plus b over x plus 4. Now since b is a -3, instead of writing plus and then the -3 there, I'll just put the minus and then 3 all over x plus 2. And then c is is a positive here, so plus 1 all over the quantity x plus 2 quantity squared. And that's the process. So that one took just about as long as the other example, which was a little bit simpler, because I caught a break here and was able to discover the value of one of the variables and just make some substitutions. Now this one over here, this one's a pip. This one, first off, Notice that the degree of the numerator is greater than the degree of the denominator. If it's greater than or equal to, your first step is not to find the form. Your first step is to divide. You're going to rewrite this guy as a quotient plus a remainder, and then we're going to do the partial fraction on the remainder. So a little scratch work over here. This is x to the third plus 0x squared plus 3x plus 0 dividing into this numerator, which is x to the fourth plus 2x to the third plus 10x to the second plus 8x plus 12. At least they're nice and neat and all a bunch of plus signs. So what times x to the third gives me x to the fourth? That would be x, 1x. So I'll put it above the x term, line those up, multiply through, that would be x to the fourth plus 0x to the third plus 3x squared plus 0x. And again, these are just placeholders there. So if I go ahead and subtract, but I think it's subtracting, so I like to add the opposite, so I take the opposite. Of course, those zeros, it doesn't matter on those. But I take the opposite and I add these cancel. That gives me 2x to the third plus 7x squared plus 8x. And then I bring down, in this case, the final term. What times x cubed gives me 2x cubed? That'd be a positive 2, so plus 2 here. Then multiply, that's 2x to the third plus 0x to the second plus 6x plus 0. And again, this is where I would subtract, but I'm going to add the opposite here. And that gives me 7x squared plus 2x plus 12. So this original problem over here, I'm going to rewrite this. There's my quotient, x plus 12, and there's my remainder, positive out in front, so I'm going to write plus 7x squared plus 2x plus 12 all over my divisor here, which I'm going to go ahead and factor. That's x squared plus 3, x times the quantity x squared plus 3. Now notice that the degree of my denominator is 3, the degree of my numerator is 2. This is what you perform the partial fraction decomposition on. So I'm not going to forget this. This is part of my answer here, but I'm going to work just on this part for right now. So I have 7x squared plus 2x plus 12 all over x times the quantity x squared plus 3. This would be a over x, linear, quadratic. So this would be bx plus c all over x squared plus 3. Well, at least it's just the two rational expressions. Let me get a common denominator. So I'd have to multiply top and bottom by x squared plus 3. And here I'd have to multiply top and bottom by x. So that would be, I'll just put the x out in front for right now. I'm going to have to distribute. So this would be, if I put it all over my common denominator here, ax squared plus 3a plus bx squared plus cx. Well, I'm going to rewrite this and put this in combining like terms, and I only have these two. So if I factor out the x squared, that gives me a plus b, that quantity, times x squared. I'll put plus cx plus 3a, my constant, all over my denominator. Now let's go back. We have, this is our original statement here, and this is what it equals. So that means that the coefficient of the x squared has to equal the coefficient of this x squared. So that gives me a plus b is equal to 7. There we go. Now I have to set the coefficients of the x's. I have a positive 2 here. I have a plus c here. That's nice, because that gives me c is equal to 2, which is good. And then my constant terms, one more color here, have to be equal to one another. Set those equal. So that means that 3a has to equal 12, which means here that a is equal to 4. And if a is equal to 4, look right here, I have 4 plus b is equal to 7. B is equal to 3. That could have been the easiest one yet. I have the key values. So this guy right here takes longer to write it out than it does to work it practically. All over my denominator is equal to the quotient, x plus 12, right, plus this, where a is 4, so that would be plus 4 over x. B is 3 and C is 2, so 3 here and 2 here would give me plus 3x plus 2. The 3 here, the 2 here, 3x plus 2, all over that denominator of x squared plus 3. And they just become more and more interesting. Rather than stopping everything and creating, I'm going to go ahead and erase quickly. I'm going to do one more example. I'll see if I can squeeze it in here where A was. So let me erase this really quickly. And then I think after you see this, you probably should be okay to handle whatever problems that are assigned, because they're going to be very similar to the ones that we're looking at now. So let me do one more partial fraction decomposition on negative 3x squared minus 5x minus 19 all over the denominator of x squared plus 3x plus 6 quantity squared. Again, that should look pretty familiar. We know that this is equal to ax plus b all over x squared plus 3x plus 6 plus cx plus d. Well, because it's quadratic, this has to be linear. Because this is a quadratic factor, it's just going to be squared. This has to be linear. So x squared plus 3x plus 6 quantity squared. Buddy, let's see what happens. I have to get a common denominator, which would be this. So I need to multiply top and bottom by a factor of x squared plus 3x plus 6. So this is going to equal, I'm going to bring it way over here, ax plus b times x squared plus 3x plus 6 all over x squared plus 3x plus 6 quantity squared plus cx plus d all over x squared plus 3x plus 6 quantity squared. Well, I'm going to put it all over a common denominator. Might need to do some more erasing here. Let's see. If I multiply this out, I have a binomial times a trinomial. I'm going to get 6 terms. Careful. So that's ax to the third plus 3ax squared plus 6ax plus bx squared plus 3bx plus 6b plus cx plus d. Let's get some common denominators here, we have the common denominator. Let's get this in descending order by combining like terms. This is my only x to the third, which is good. Okay, this is x squared, this is x squared. So these two, I factor out the x squared, I get 3a plus b x squared. I'm going to cross these out so I don't get them confused anymore. This has an x, this has an x, and this has an x. So plus, this would be 6a plus 3b plus c x. And then these are my constants, plus 6b plus d, and that's all over my common denominator, or my denominator of x squared plus 3x plus 6 quantity squared. Now remember, this guy equals this guy. So what does that tell me? It tells me that the coefficient of the x cubed must equal the coefficient of the x cubed up here. There is no coefficient of an x cubed. There's no x cubed term. So that would be like 0x cubed. So that means that a has to equal 0. That's good. Then I have 3a plus b has to be equal coefficient of the x squared to negative 3. So 3a plus b has to be negative 3. So the coefficient of the x term has to equal here negative 5. So that's 6a plus 3b plus c has to be negative 5. And that means that the constant term, 6b plus d, has to be negative 19. Well, some of this falls out because I have a is 0. So if a is 0 here, if I put a 0 in here, that means b is negative 3. And if a is 0 here, this cancels out. That gives me 3 times negative 3 plus c is equal to negative 5. Negative 9 plus c is equal to negative 5. C is 4. Okay? And if c is 4, well, I really only need b here. So that's 6 times negative 3 plus d is equal to negative 19. Negative 18 plus d is equal to negative 19. D is negative 1. And that works. Now, I know at times when I'm going through a problem like this and it's got lots of steps, I might be going a little bit faster than you like, but remember, you can always push pause and then get caught up with whatever you're doing, or wind it back a little bit and go back over it. So now I have these values, and that goes right in here for all of these guys. Now, I didn't give myself much space, so I'm going to really cheap out with the way I write my answer. I'm just going to go ahead and add it on to here. Well, we don't know about that sign yet, so let me put this down. So what will this equal? Well, a is 0, so that means this is gone. B is negative 3, so there's a negative 3 here. D is negative 1, and C is 4, so I'll leave the plus here, and I'll write 4x minus 1. And that's how that breaks apart, how it decomposes into that. All right, now, I can tell you, one silly little mistake, a sign, not combining like terms, anything like that in a problem like this, and it's just going to all fall apart. So if you start getting just some really obnoxious looking fractions, there might be a possibility that you messed up. Now, you can get fractions. Like, for example, if I have, I don't know, let's say a over x plus 3, and it turns out that a is 2/3, you can put the 2/3 in there. This would be like 2/3 over x plus 3. Now, I wouldn't leave it that way because it's, you know, it's a complex fraction. I would probably multiply top and bottom by 3 and write that as 2 all over 3 times the quantity x plus 3. And that would look a little bit better in that form. But you can get fractions for these constants. But they're usually reasonably simple fractions. They don't get into, you know, high double-digit denominators or definitely triple-digit denominators. So the only way you're going to get better at this, you probably already know what I'm going to say, practice, practice, practice.